Okay, here's part 2 of your pre-calc lecture for 7.1.2. We're just going to do this one problem at 7-17, and it wants us to sketch the graph of this function. So again, I looked at it as being a reciprocal function, like our parent function, and it was moved down by 1 and right by 4. So that's why I have this asymptote down by 1 and to the right by 1, 2, 3, 4. And you can just sketch it in. I actually plotted a couple points to make sure it was accurate. So I'm supposed to complete these limit statements. So we just learned this a second ago, but it says, what's the limit as x approaches infinity of f of x, this being f of x? So what's the limit as x approaches infinity? So if you're approaching infinity, you have to approach it. They don't have to say from the right or the left, because you can't approach it from the right, because it's infinitely off to the right, isn't it? So we're going to approach infinity, and where does the bug think he's going if he's approaching infinity? Like, what y value is he going to go to if I follow this? Aren't I getting ever so close to this dotted line, which is -1? So that's how you answer these. You say, well, where does Benny Bug think he's going? Where do the y values go as x, basically, where do the y values go as x goes to infinity? The y value goes to -1. So we're just going to say -1. That's not an 11. It's just a bumpy table. It's -1. Okay, so then this one says the limit of f of x as x approaches 4 from the left. So this is 4, but I'm coming in from the left. So basically my graph, as it comes in from the left, it's this red part of the graph on the left. And as I approach 4, I'm going to get ever so close to 4, which is this asymptote, by the way. But I'll never quite hit 4, but I'm going to get infinitely close to 4. And what's happening to my y values? As x gets close to 4, my y values they're taking a nosedive. So my y values are going to -infinity. So I could say that the answer is -infinity, but your answer book will tell you a different way. Your answer will say DNE, which means does not exist, but f of x goes to -infinity. So we just wrote -infinity. But the reason they're saying it does not exist is because as you go to -infinity, you will never ever get there. Like, you can never get to -infinity, so I guess that's why it doesn't exist. So you'll see that in your book. So if you wrote -infinity, I wouldn't mark it wrong. If you wrote DNE, I wouldn't mark that wrong either. I'm probably going to stick with the infinities. And then this one says what happens, or it says what's the limit of f of x as x approaches 4 from the right. So remember, 4 is our asymptote, and I want to approach it from the right, and there's 4, that dotted line. I'm getting so close to 4, I'll never quite get to 4. And where do I think I'm headed? I'm going way, way up. I'm going to go to infinity. So I'm just going to say infinity. But with the infinities, we say, your book will also say, another way to write this is DNE, but f of x goes to infinity, or something like that. Well, this would be -infinity. DNE. Something like that. And I think that's all you need to know to be able to do your homework. This is just like the building block of what a limit is, and then we'll learn more about that next time.